In this video, we solve one material handling system simulation problem. So basically, what is material handling system? It is carry material from one place to another place effectively. Hello friend, in this video, we solve one material handling system simulation problem. So basically, what is material handling system? It is carry material from one place to another place effectively. Means whether our material system capable or not for given plant, means effectively whether it is used or not, means output should be equivalent to input. So I'm just take or solve one problem on simulation. So in this problem there is a one source, we have one cube, means peak point, and second is sink, that is drop point, and we use one executor. The capacity of that executor having 3 products in each time, or at a time they can pick 3 products and having certain capacity. So this is one small problem we can execute step by step. So for that we require certain information about this. So this is our problem statement, that analysis of material handling system, that is modeling simulation for selected plant layout by using Flexi 2020. So plant use an automated guided vehicle for handling the product, and input resources according to just use one source having arrival time 3 minutes, queue having capacity 10,000, batch size 3, controlled or operated by guided vehicle. Then for automated guided, that is we use task manager and having capacity 3 and speed 60 meter per second. Sync, that is output. Then we will run this model for 24 hours, and we should find total part arrival, that is input, and dispatch output, average time required to part to dispatch, and average work in progress. So our ultimate main objective, that how this material handling system work effectively, means whether output nearer to 100% or not. So we'll start steps. File, then select on new model, discard this problem, then define time in minute, remain term as it is, length in meter, and we not require fluid, so okay. Then first draw layout, that is layout of plant. So we required AVG library, draw straight path. So model view from top side, we observe this all layout from top side, draw straight path. So it is important that direction of this path is unidirectional. So maybe you consider from clockwise or anti-clockwise according to requirement. Next, straight. If you observe carefully, I am just select all lines in unidirectional, then join that all lines by using join path. So select join path, then select one and another. So you can see the arrow Then next, similarly, do this job for remaining corners. Sorry. Okay, in this way we create plant layout. Then next step, we create object, means we require source, queue, sink and control points. From fixed resources we use or we select source, then one queue and one sink, that is output, and place according to convenient. Next, we require control points, so open AVG library and select control point from AVG, select, and first control point place nearer to Q1 and second place nearer to Q2. Point should be on network line. The next step, that is connectivity. So connect all objects. First start from source to queue and queue to sink. Next, we connect control point to queue as well as sink. So this is first control point. Select first control point and connect to the Q1. Again connect second control point, that is drop place and sink. After that we place a task executor which will use to handle the material. So select task executor from task executor library and place inside the layout. After that connect task executor to control point. So we'll connect task executor to this first control point and select travel AVG. After that reset, means that executor place on control point 1. Next step, that is connect queue to task executor by central port. Select connect central port, that is S, then select queue and connect to the task executor by central port. Then next step, that is define property. We'll start from source. Select source. In source we define only arrival time, so we already select time in minutes, so here we define arrival time, that is 3 minutes according to given. After that property of queue, double click on Q1 and capacity according to maximum content, by default that is 1000. Then perform batch, target batch size 3. Then waiting time should be 0. Then flow, in flow we use external transporter, so select use transport and apply and okay. After that we give property to task executor. So in task executor, according to given 2 properties are important, that is capacity of the task executor and speed, that is 60 meter per minute. So apply and okay. After that, last, that is network property. For network property, we require just to attach the load on that network. So just click on attach load as a trailer, apply and okay. In this way we complete our object parts, then their connectivity and their respective property according to given conditions. So reset all things and run this model for 24 hours, that is in terms of minute 1440 minutes, and run it. So we can manage the speed. We'll run this model for 24 hours and increase run speed. So after 24 hours, input that is 479 and output near about 477. Means we can say that one AVG, that is one task executor for given condition, is suitable and it gives near about 100% output. If you're not satisfied with this condition, you can adjust task executor speed, then capacity, then queue properties, batch size. In this way you can adjust these properties and simulate as per requirements. So ultimate goal of material handling to make available the material where it is required and to carry material effectively. And there are a number of functions